Okay, hello everyone, welcome to the RCNP course. In this part, we're going to introduce the RSTP. And firstly, let's see some basic concepts of RSTP. RSTP is the Rapid Spanning Tree Protocol. And let's see, actually is developed based on the STP, which we just introduced. Since the STP has some shortcomings, the first is a long recovery time. It takes at least 30 minutes. It takes at least 30 seconds, or it takes at least double forward delay time for ports to switch from the blocking state to the forwarding state. After the network topology is changed, it takes maybe such a long time to recovery. If the network topology changes frequently, network is disconnected frequently. So to solve this problem, let's see how does the RSTP works. RSTP is developed based on STP and has the same implementation principles as those of STP. RSTP has all STP functions and is compatible with STP. RSTP aims to recover network connectivity quickly, when the network topology is changed. And let's see some difference between RSTP and the STP. First is fewer port states and more port rules, different BPDU formats and sending methods, more faster convergence mechanism. RSTP can recover network connectivity quickly when the network topology is changed. So at this part, we're going to introduce the aspects of RSTP, which is different from those in STP. First is about the port status. Since RSTP has fewer status, so let's see it. For STP, we still remember it had 3 port status. For STP, we still remember that it has 4 port status: blocking, listening, learning, forwarding. While for RSTP, it only has 3 port status: discarding, learning, and forwarding. Okay, because actually for STP, both blocking and listening, actually, they don't have any difference, actually, because both of them do not send the service data and they do not learn any MAC address. So in RSTP, we modify it. We only have 3 port status: discarding, learning, and forwarding. Next, RSTP has more port rules, except the RP, DP, AP. And we have a backup port, the backup port of the DP. Okay, so in this way, let's see this case. Alternate port is a backup of RP. Backup port is a backup of DP. So the alternate port and backup port in RSTP is the same as alternate port in STP. And let's see here. Now is the AP and is blocked. BP is also blocked. But when the RP of SW2 is 40, so we can just enable AP, right? And when the DP on SW3 is forged, we can just enable, or we can just activate the BP. It can make the recovery of the network more faster. Okay. And next is about the BPDU of RSTP. In RSTP, the BPDU is called RST BPDU. Spanning trees are calculated based on RST BPDUs. And what's different is the message type and the flag fields. For the message type, it is set to 02, indicates that this is the RST BPDU, or indicates that this is the BBDO of RSTP. And for the flag field, in STP, only bit 0 and 7 are occupied, while in RSTP, bit 1 to 6 are also occupied. And let's see the function of them. Bit 1 and the 6 indicates proposal and agreement, respectively, and are used for PA mechanism. Bit 2 and bit 3 indicate port rules. 0, 0 indicate unknowing. 0, 1 indicates AP or BP. 1, 0 indicates RP. And 1, 1 indicates DP. Bit 0, bit 7 indicate the TCN and TCA. Bit 3, bit 5 indicate the learning and forwarding states, respectively. So this is the difference between the RSTP BBDO and the BBDO in STP. If you use some tools to capture the BBDO, you can see the fields of the BBDO flags. You can see each bit of the BBDO flags, and they represent different messages. And next, let's see the RSTP BBDO processing method. It has independent hello. After RSTP topology becomes stable, non-root bridges automatically send configuration BBDOs with hello time as an interval, regardless of whether they receive a configuration BBDO from the root bridge. This is different from that in STP, because in STP, only when the non-root bridges receive the BBDO from the root bridge, they will learn it and forward it to the downstream switches. But in RSTP, no matter if the switches receives RSTP BBDO from the root or not, they can generate and send the RSTP BBDO periodically. Next is a quick fault locating. If a non-root bridge does not receive a BBDO from the upstream device for 3 consecutive hello time intervals, the upstream device is 40. And the fast convergence, when a downstream device receives a BBDO from an upstream device and finds that the BBDO received from the upstream device has a lower priority than the BBDO received by the local port, the device sends the BBDO received by the local port to the upstream device. After receiving the BBDO, the upstream device makes a comparison and updates the BBDO received by the local port. This is about the fast convergence method of RST BBDO. After knowing these concepts, next let's see how does the network recovers when we use the RSTP. First is the quick RP switching. The RP on SW2 shuts down abnormally, which is here. If this port is abnormal, in this case, AP on SW2 becomes the RP, enters the forwarding state, means we will activate this port on SW2. You can see here. And through the link where the AP resides, there is an AP that can reach the root bridge. So it will become the new RP. This is the reason why we say that AP is the backup of RP. And the next is a quick DP switch. The DP on SW3 shuts down abnormally. So this port, you can see this port is 40. And the BP on SW3 becomes the AP and enters the forwarding state. Because the BP serves as the backup of the AP, it provides another path from the root bridge to the responding network segments. So this is the reason why we say that the BP is the backup of DP, because when the DP is 40, BP will become the new DP. Okay. And next, we mentioned a mechanism which is called the PA, proposal agreement. PA mechanism indicates a proposal agreement mechanism. With this mechanism, RSTP accelerates the speed of upstream ports entering the forwarding state. In RSTP, when a port is elected as a DP, it first enters the discarding state and then quickly enters the forwarding state through the PA algorithm. In STP, the port needs to wait at least one forwarding delay to enter the forwarding state to prevent loops, while RSTP blocks non-root ports to prevent loops and accelerate the speed of upstream ports entering the forwarding state. So we will see it. How does the PA mechanism accelerate the speed? Between the root and the switch 2, they can exchange the proposal and agreement PBDO and can quickly enter the forwarding state. But how does it work? Let's see it. If a link is added between the root bridge and SW3 in a stable RSTP environment, how does RSTP perform convergence again? Let's see it. The port between the root bridge and SW3 becomes a DP, sends RSTP BBDO. Now we add a link between the root and the SW3. When the port P1 on SW3 receives the RSTP BBDO with a higher priority, it knows that it will become the RP instead of DP and stops to send the RSTP BBDO. The DP of the root bridge enters the discarding state and send RSTP BBDOs with the proposal bit set to 1. You can see. And after receiving an RSTP BBDO with a proposal bit sent to 1 from the root bridge, SW3 sets all ports to be synchronization state. Pay attention here. This is important. This is the function of the proposal SW3 set all ports to the synchronizing state. Synchronizing state means these ports are blocked temporarily, actually. After the ports on SW3 are in the synchronizing state, downstream port P0 enters the discarding state. You can see this port P0 on SW3 is blocked temporarily. And upstream port P1 enters the forwarding state. So it can enter the forwarding state immediately. Don't need to wait for 2 forward delays. And send the RST BBDO with the agreement. So it will feedback with the agreement bit set 1 to the root bridge as the response. After receiving RST BBDO with the agreement bit set 1, DP of the root bridge enters the forwarding state. So this port, port 1, P1 on the root will enter the forwarding state. So in a very short term, these 2 ports, P1 on SW3 and P1 on the root, have entered the forwarding state. So they can forward data in a very short term. And for all the downstream devices, they will repeat this process. So the whole topology can enter the forwarding state, can forward packets in a very short term. For example, SW3 will send maybe proposal to SW2. SW2 will block the ports and maybe respond with the agreements. So this link will enter the forwarding state, right? This is the proposal agreement mechanism. Since all the downstream ports has been blocked, so we don't need to worry about the temporary loop in the network because they are blocked. Even the link between the root and the SW3 has already forward data since the downstream ports are blocked. So there's no loop anymore, right? Okay, so this is the PA mechanism and how does it solve the problem of temporary loops in the network. And next, let's see the configuration of RSTP. Firstly, configure the STP mode by using the command Spanish tree mode RSTP, right? And then configure the bridge and the port priorities This is optional. You can use these commands to change the priority so that you can control the election result, right? For example, if you want one of the switches to be the root, so okay, you can manually change the priority of the root. Or if you want maybe one of the ports to be the root port, so you can manually maybe change the priorities to affect the result of election. The command is shown here, spanning tree priority. For example, spanning tree priority 496. And the default value here is 32,768. Next, config the port pass cost. This is also optional. You can configure it to affect the election, right? Spanning tree pass cost method, long standard, short. They indicate different standards of the port pass cost, right? 802.1D, 802.1T, right, and so on. Or you can, this is maybe changing the port pass cost by modifying the standard they use, or you can directly set the pass cost to a specified value, spanning tree cost. For example, spanning tree cost 20, spanning tree cost 30, right? And this command is used in the interface view because you are modifying the pass cost of one specific interface. Okay, and then configure the STP time parameters. Time parameters include the hello time, the forward delay time, and maybe the max age, right? These kind of timers are called time parameters, and this is optional. Okay, you can see the commands here, and these commands are seldomly used. Next is the faster convergence. Change the link type, spanning tree link type point-to-point or spanning tree link type shared. By default, the connection type is point-to-point for 4 duplex ports and shared for half duplex ports. And last, enable the STP function. Since the STP function is disabled by default, so you should manually enable it by using command spanning tree. Okay, this is about the running principle of RSTP. But no matter STP or RSTP have their shortcomings. RSTP only generates one spanning tree on the entire switching network, which cannot solve the data wheel-rated performance due to the network score expansion. When RSTP is used, it is recommended that the number of devices between any 2 nodes does not exceed 7. So RSTP cannot support maybe a large network and a complex network. RSTP can only achieve redundancy and backup, cannot perform load balancing based on VLAN traffic. Okay, so this is a shortcoming of RSTP. And to solve this problem or to overcome these shortcomings, at the next part, we're going to introduce the MSTP. Okay, before the RSTP, let's see the question. Which of the following option is not RSTP port status? Discarding, learning, forwarding, blocking. Obviously, we choose blocking. And the next, which of the following statements are true in comparison with the BPDU processing method of RSTP and STP? Let's see them. Choose A, RSTP follows the transmission mode of BPDUs configured in STP and sends them periodically only from the root bridge. Is false. Because the first part is true. They send the BPDUs periodically, but not from the root bridge. Each RSTP bridge can send the BPDUs independently. And B, the aging time of RSTP BPDUs is required from max age to 3 consecutive hello times. It's true. And C, in RSTP, a blocked port can respond immediately when receiving a low priority BBDU is true. D, after receiving the configuration BBDU, the RSTP switch calculates and compares the priority direction in the same way as STP. And it's true. So here we choose B, C, and D. Okay, that's all for this part about the RSTP. Thank you for your listening.